This video is just for the calculator part of the review. So starting here, it says a wheel has a diameter of 38 inches. So let's write down radius is 19 inches. The wheel is spinning at 3,000 revolutions per minute. That's related to an angular speed. So theta, if we have 3,000 revolutions, remember that means 3,000 full circles. A full circle in radians is 2 pi. So we'll multiply that by 2 pi. And then the per minute means there's been a time introduced of 1 minute. Determine the linear speed of the wheel in inches per second. So I have the radius in inches. The 1 minute should be changed to 60 seconds, just to get my units in order. And remember, linear speed is just arc length, distance traveled, divided by time. So arc length is the distance traveled. Imagine there's paint on this wheel. If it were to spin 3,000 times on the road, how long would the stripe be that it's making? It's basically what the arc length represents. And then the time is going to be 60 seconds. So from the beginning of this chapter, we know that theta in radians is defined as the ratio between arc length and radius. So if I solve this for s, arc length is just r times theta, as long as theta is in radians. So r times theta over time. And then r is 19. Theta is, let's just make this 3,000 times 2, 6,000 pi. And we're going to divide by 60 seconds. And that will give us our linear speed. So that was 19 times 6,000 pi divided by 60. So this is about 5,969.026. And the label right now is in inches per second, which I believe is what it was supposed to be. Yeah. All right, so that's it for the first one. For the second one, it says, assume that the Earth is a sphere with a radius 6,378 kilometers. Syracuse, New York, and Annapolis, Maryland have a difference of about 4 degrees in latitude. Use this information to find the distance. Distance on a sphere is the arc length between the two cities. So right now we have this. The two cities are 4 degrees apart. We're trying to find S, and we have a radius of 6,378 kilometers. We can't use our arc length formula if the angle is measured in radians. So the first thing to do for theta is change it to 4 times pi over 180. That will change 4 degrees into radians. So you could reduce that if you want. 4 divided by 180 is pi over 45. Okay. And then again, our arc length formula S is equal to R theta. That's just the rearranged radian formula. And I should just be multiplying these numbers together. This will give me my answer in kilometers, and it doesn't specify what unit I have to be in, so I'm just going to leave it like that. So times pi over 45. So 445.268. And that's measured in kilometers. Always include your units of measure, whether it's for my quizzes and tests or especially the AP exam. A motorcycle has a diameter of 19.5 inches. All right, so we've got to cut that in half, right? Half of 19 is what, 9.5? Half of a half is 0.25. So you can also just divide by 2. So 9.5 plus 0.25 is our 9.75. So R is 9.75 inches. We're rotating 1,050 revolutions per minute. So remember, revolutions are the number of full circles that theta has rotated. And this one gave me a time of 1 minute. Part A says find the angular speed in radians per second. So I just need to change minutes to seconds. And theta is in radians because I multiplied revolutions times 2 pi. So the angular speed should just be 1050 times 2 pi divided by 60. So that's 109.956. And then that measure is radians per second. The other question says find the linear speed of the wheel in inches per second. So linear speed, remember that's arc length, that's distance traveled divided by time. Arc length is r times theta divided by time. So r is 9.75. Theta is 1050 times 2 pi. And we're dividing by time, which is 60 seconds, just because this says inches per second instead of inches per minute. Okay, so typing all of that in. So I'm getting the linear speed is 1072.068. And then this would be inches, because that's what the radius was in, per second, and that's what I needed. All right. So that's sort of the linear speed, angular speed. It's really just theta equals s over r and manipulating that. Linear speed is arc length over time. Angular speed is radians over time. Now we're on to the right triangle trig stuff. So this one, 25-foot ladder is leaning against a wall at an angle of elevation of 67 degrees. So the ladder is the hypotenuse. Assuming the wall is vertical, it makes 90 degrees. Angles of elevation are always from the horizontal to that terminal side, so that's 67 degrees. And it says the base of the ladder is 5 feet from the base of the wall. How high up the wall does the ladder reach? I actually didn't need, I think I have too much information in this one. So I didn't actually need the 67 degrees for this one. I can just do Pythagorean theorem, right? So that should be okay. So x squared is equal to, x is equal to the square root of 25 squared minus 5 squared. Let's just see what that comes out to. I think I meant to fix that. I just forgot about it. That we have too much information for this one. Okay, so, excuse me, so 24.495 feet is about how high up the wall is. About how high up the wall this is. Okay, so we didn't actually need the 67 degrees. Although let's just check this. Now, I might have made a flawed problem in this if I didn't check the angle. But let's just see, like, it should be that 25 times the sine of 67 gives me the answer. But I need to switch to degree mode. So I'll get the answer, and then I'll switch to degree mode. Yeah, so we do get slightly different answers because I think I just made up the 67 and didn't actually check with the numbers in there. So the angle would have to be different if these were the two side lengths given. So anyway, we'll ignore the 67. I'll make sure that I tell you guys that. All right, find the length of a skateboard ramp if the angle of elevation is 18.4 degrees and the vertical rise of the ramp is 4 feet at its highest point. So we have some sort of ramp. Find the length of the ramp. Let's call that x. The angle of elevation is 18.4 degrees. The vertical rise at its highest point, so this vertical side here, is 4 feet. Find the length of the ramp and find the horizontal length of the ramp. So just call one of those x and one of those y. All right, so x would be solved with sine. The sine of 18.4 degrees is equal to 4 over x. To solve for x, you multiply x over to this side. I noticed some of you did this incorrectly on your quiz, so be careful with this. You would divide by sine. So it's not always just multiplying the numbers together. It depends on how the ratio is set up. All right, so this is the length of the ramp. 4 divided by the sine of 18.4. So 12.672 feet. So that's the length of the ramp. And then y would be, use the 4 again. Don't use the x value that we rounded. So y would need to use tangent. The tangent of 18.4 degrees is equal to 4 over y. And then similarly, when you solve for y, you're going to be dividing by tangent of 18.4. And that comes out to 12.024. And that's feet. So once you get the picture for the right triangle trig problems, hopefully it's a little easier to solve these. Okay, what about this one? We had this a few times on our reviews and quiz for the last quiz. So 2 boats are spotted by a person at the top of a lighthouse. So here's a lighthouse. Someone's at the top. The boats are on the same side of the lighthouse. Angles of depression to each boat are 20 degrees and 16 degrees. So we spot one boat and then we spot another boat. You do need to put the angles in the correct order. Now, I know I listed them 20 and 16, but if I would have switched the order, you just have to pay attention. This is the steeper angle, so this has to be 20 degrees, and this one is less steep, so that has to be 16. If the boats are 111 feet apart from here to here, how tall is the lighthouse? So this is one of those that has 2 unknowns because we don't know the height, but we also don't know how far this boat is from the lighthouse. So maybe I like calling vertical distances y and horizontal distances x. Now, if this is x, we have this triangle here where the tangent of 20 degrees is equal to y over x. And then in the larger triangle, this entire leg down here is x plus 111. So that one's going to be the tangent of 16 degrees equals y divided by x plus 111. Now, my goal is to solve for y, so I like rearranging these 2 equations to solve them for x so that I'll have y's left in my equation when I put them together. So what that means is I like doing this. X times tangent of 20 equals y. X plus 111 times tangent of 16 equals y. I could set these equal to each other at this point, but then the only variable will be x. So I'll be finding x, and I'll have to go back and solve for y. So instead, I'm going to keep rearranging. Solve this for x. X is equal to y over tangent of 20. And over here, you can divide y by the tangent of 16. And then to solve for x, you're going to subtract 111 over to the right side. Now these 2 equations can be set equal to each other, and you have just y's left in your equation. So y times the tangent of 20 degrees equals y times the tangent of 16 degrees minus 111. Whether you got this to be set the x is equal or the y is equal, you have to get the variables on the same side. So y over tangent of 20 minus y over tangent of 16 will equal negative 111. And the reason we get the y's together is so that we can factor a y out. That makes it 1 over tangent 20 minus 1 over tangent 16 equals negative 111. And I'm kind of out of room here, but my answer to y is going to be negative 111 divided by those parentheses. So let's see what that comes out to. So negative 111 divided by, parentheses around the denominator, 1 over tangent 20, close the angle, minus 1 over tangent 16, close the angle, close the denominator. And so for y, I get 150.013. And that's measured in feet. And that's my final answer. I was trying to solve for y, and I have y. If you did it the other way and you got an answer for x, you need to remember that way back here, y is equal to x times tangent 20. So if you got an answer for x, you need to multiply that answer by tangent 20, and you should get what I have exactly. All right, let's see this calculator problem. So a person is standing 200 feet from the base of a building, 200. The angle of elevation from the person to the top of the building is 26.5. The angle of elevation from the person to the top of a flagpole sitting on top of the building is 31. So let's just say the flagpole is here. Find the length of the flagpole alone. So let's put in our two angles of elevation. So the first elevation to the top of the building, 26.5. And then you have to look higher. So this angle is 31.0. We don't know the height of the building, and we don't know the height from the ground to the top of the flagpole. But once we find those two things, the height of the flag is y minus x. So there are two triangles here. The smaller triangle needs a tangent equation. The tangent of 26.5 is equal to x over 200. So solving for x is just multiplying the 200 over to the other side. And then the tall triangle is still a tangent equation. It's the tangent of 31 degrees, and that's equal to y over 200. So y is 200 times tangent of 31. And remember, the height of the flag, or the length of the flagpole alone, is y minus x. So 200 times the tangent of 26.5, minus 200 times, I just started typing this in the wrong order. So I'm going to get the answer, but it's just going to be negative. So I should have flipped the order for that. So the answer should be 20.456. If I go back and just fix my angles, let's just verify that. 31.0, 26.5. Yeah, okay. So that is, and that's feet. All right, and then what we did most recently was solving for theta if you're given the value of a trig function. So remember, we did these algebraically once, and then we focused on doing these graphically. You should be able to do them graphically for the AP test, but you need to know how to set up the window. So this is a domain. The inputs are theta, and theta has to stay between 0, which is the x min, and 2 pi, which is the x max. And your y value here just needs to fit for the range. You just need to be able to see this value. So I usually go -2 to 2. That's a nice wide window that captures most of these problems. So let's just set it up like that. So this is going to be clear out the old stuff. I can't get to y1 for some reason, so just wherever this takes me. All right, so cosine of x, and then the other line is going to be -0.7541. Adjust the window 0 to 2 pi, -2 to 2, and then just press graph. Oops, I'm in. Okay, and then if you just see horizontal lines like this, we need to switch our mode because this is degree mode. So switch that to radian mode because the angles are in radians, and then try that again. That's better. So we want to find the intersection. So this one happened to find the one on the right first. I don't care what order you write these in. So this is 3.858 radians. And the other intersection points, you're going to have to move the cursor so it gets closer to the one on the left. Enter, enter, enter. And 2.425 radians. And those are my solutions. There are no labels on radians because theta is really just a ratio. It doesn't have like a unit. It's a ratio between arc length and radius, so the units cancel out. You can write the word radian if you want to. But it's the same way, like we don't label sine, cosine, and tangent values when we write them down. Okay, now cotangent, we need to switch. This is tangent of theta equals 1 over 0.2598. Now, this reciprocal might not show up in this window, so it's worth your time to go back to your home screen and see what it is. 1 divided by 0.2598. Like 1 over 0.25 would be 4. So, okay, so this is just outside of the 2 range. So I'm going to switch this range. Let's write down what this was. 3.849. Now, don't use the rounded version in your y equals. Use this, but this was just to help me adjust my window. So let's make the range, let's just go -4 to 4. That way that'll show this. All right, so I'm going to type this in as y equals tangent of x. And then, again, don't use the rounded 3 point whatever number. Do 1 divided by 0.2598. And then we just press graph. Oh, no, we don't. We adjust our window. -4 to 4. And it's just up there. I could have bumped it up to 5 or something, but as long as you can see the intersection on your screen, it should be fine. So I'm just going to enter, enter, enter. Found this one for me. So theta is about equal to 4.458. And then to find the other one, it's kind of weird on a tangent graph. But remember, we're like up here, so we need to scroll to the left. Or you could hop to the black line and get it closer there, but I'm going to scroll to the left. Eventually, my cursor is going to disappear, but then eventually it'll hop up here. There's a vertical asymptote. And so it will eventually come back. There it is. So enter, enter, enter. 1.317. Both of those are answers in radians. And then final question here. What are the answers for problems 8 and 9 if I ask for all possible answers for theta rather than just the answers that are between 0 and 2 pi? So all you have to do, and we will need to do this for our AP test, is write down one of the angles that you got and add 2 pi k. K is an integer. And this just says that we can add or subtract any number of full circles. So this basically says all coterminal angles to this one are also solutions to that equation. And you would have to do it separately for both. But it's every time, it's plus 2 pi k. It's not going to be anything else ever. You do have to write the k as an integer part, or you can use the notation shorthand kes. K is an element of the integer set. For 9, it would be theta is about 4.458 plus 2 pi k. I'm going to write the k as an integer thing in a minute. On a test or quiz, I'd be okay with you saying the whole thing, k is an integer. That's it.